Good evening. My name is Seth Hakizimana, a maths tutor for Hakiz Intensive Maths Tutoring and Vivid Maths and Science. Today I'm going to discuss an important topic, which is the trigonometry. Trigonometry is a topic in paper 2, which cut for most of the marks in paper 2. In one of the evening, I viewed Trig and I was able to categorize questions in this section into 5 families. As I discuss these families, let's share with you the skills that a learner needs in order to cope with the questions in the trigonometry. The first family, I'm sure you are able to see my screen. The first family deals with the questions that require the use of Pythagoras. We have got Pythagorean-based questions, of which I have already spoke about. The second family deals with the issue of trig expressions. Should have opened my pen. Yes. The second family deals with the trig expressions and also proving identities once you have got 2 expressions. The third one deals with the trig equations, where you spoke about the general solution, or once you are given the domain, you come up with a specified solution in the given domain, or question dealing with the undefined. Family number 4 involve questions that deals with the 2D and 3D. In the 2D and 3D, it's mostly the grade 11 work, area rule, sine rule, cosine rule, but also part of the compound angle and double angle, and reduction and correlations. Now, today, we are discussing mostly questions that we found in family number 5. Family number 5 that deals with the trig graphs. Trig graphs, in short, we should be able to plot, to read, and interpret trig graphs. Then there is also interpretation as around the amplitude, vertical shift, horizontal shift, and change in the period. But sometimes you find a question that will involve general solutions or solution in specified domain, and also the use of square identity, double angle, and compound angle appearing also in this section. And also one of the things that I would emphasize the most on this section is the effect of period. Effect of period in determining the critical values or critical angles that would give us y-intercept, x-intercept, the turning point, meaning maximum and minimum, and that helps us in plotting the trig graphs. We would also look how we can use calculator, the table in our calculator, in order to get these critical values. So without much of the finishing of the time, let's start with the questions. So we have our first question here, which is asking us to sketch that 2 sine x minus 1. Yes, that's a graph, meaning y equals 2 sine x. So now here, the period. So period is equal to 360. If we divide by 4, we will get 90 degree, which means we can have our critical values. Our critical values we've got here. Let's make a table. I've got x and we have got y. Okay, we can actually go to the calculator. We go 7, then we have got 2 sine x minus 1. What is our starting point? We are starting from 0 degree. We will end at 360, and our steps will be 90. Okay. Now we have got a 0. Here we have got 0 degree, then 90, 180, 270, 360. Then here we've got minus 1. Then we've got 1. Then we've got minus 1, minus 3, minus 1. Now we make our Cartesian plane. So here we have got 90, 180, 270, and 360. Here we have got 1, 0. Here is 2, minus 1, minus 2, and minus 3. Normally, if I look, our graph has been stretched 2 units and brought down by 1 unit. So I can imagine this as being my new, let me change my color of my pen. I imagine this as being my new origin or my x-axis. Yes, my new 0 here. Yes. So then I have got at 0 I have got negative 1. Okay. At 90 we have got 1. At 180 negative 1. At 270 negative 3. Negative 3. And at 360 negative 1. So now I will go up, come down, and then go up again. So this would be my, this is y equal to sine x minus 1. So that's how our graph will look like. So I've got my second question here, where we have got y, but this one I can change. We've got y equals 1 minus 2 cos x. This is the same as y equals minus 2 cos x plus 1. So then I can able to So I see again, my period did not change. Period is equal to 360. If I divide by 4, I have got 90. So I'll be having an increase of 19. So then I can have my x, and I have got my y, which is negative 2 cos x plus 1. Cos x plus 1. So I'll be having here 0, 90, 180, 270, and 360. Then I can go to my calculator again and put, I've got minus negative 2 cos x plus 1. Then the starting will be 0 degree, the end 360, increase 90. Then here I have got negative 1, that is 0. I have got negative 1, 90, I've got 1, 180, I've got a 3, 270, I've got 1, 360, negative 1. So now I can have my Cartesian plane. Okay. Oh yeah, I've got 90, 180, 270, and 360. 1, 2, 3, 3, 2, 1, negative 1, negative 2. Sorry. Now at 0, I've got negative 1. 90, I've got 1. 180, I've got a 3. 270, I've got 1. And 360, I've got negative 1. Negative 1. So then I'll go up there and come down. So that will be my graph. So this is y equals negative 2 cos x plus 1. Okay, that is excellent. Now our question C, this is a question that has a horizontal shift. We have cos x plus 60, meaning we have shifted this 60 degree to the left. Our period is still 360, so you make our period is equal to 360. If we divide it by 4, we are going to have 19. So now, if we look what was at 0 degree is going to be at negative 60. And what was going to be at negative 90, okay, would it be at 150. So meaning we expect to have some critical values. Our critical values will be at negative 60, then negative 150, then it will be again at 30, because this, if you add 90, it will be at 30, then at 120, yes, then at 210, then at 300. So now those are the critical value we are looking for. Now let's go to the table and then see what the table will give us, if it will be the same as what we are expecting. So it is cos x plus 60. Yes, and then our starting point is minus 150. Our end point is 300, and our steps would be 90. Yes. Now here we have got our table. We've got the x, and I've got cos x plus 60. Okay. We are starting from negative 150, and then we go to negative 60. Then we go to 30. We go to 120. Then 210 and 300. That's perfect. So there we've got a 0. Then we've got 1. Then we've got a 0. Then we've got a negative 1. Then we've got a 0. And we've got 1. Then we can be able to put our Cartesian plane. Oh gosh. Let me remove this one. Okay. So we'll put inside here. Good. Then here we've got minus 60. Here we've got minus 150. We've got 30. Here we've got 120. Here we've got 210. We've got 300. Okay. Now our zeros are here. 30 to 10. Our maximum is at negative 60. Oh, here's 1. Here's negative 1. Negative 60, we've got our maximum. And also 300, we've got a maximum. Our minimum is at 120, negative 1. Yes. So now we go up, come back down, and go up again. So we are looking at the zeros, the intercept with the x-axis, the maximum turning point, and the minimum turning point, then the first number and the last number. Very important. And this is our y equals cos x plus 60 degree. So we are able to see the horizontal shift in this graph. Now our question D is a typical example where the period has been changed. Here means put two graph into a 360. So our period will be equal to 360 divided by 2, which would give us 180. Then our critical angles or critical value will be equal to 180 minus divided by 4, which gives us 45. So our jump will be by 45 degrees. Yes. So then we can have our x values, and we have got a y value, which is 1/2 cos 2x. Okay, we start from negative 90, then negative 45, then 0, then 45, 90, 135, and 180. Then we know those would be our critical angles that we need. Then we can again use our calculator. Our f of x is a half, then cos 2x, 2x. That's it. And then we are starting from negative 90. We are ending up at 180, and our jump is 45. So very important. Now we have got, this is minus a half, minus 1/2, and this is giving us a 0, a half, 1/2, and this gives us a 0, negative a half, and this gives us a 0, and then a half. Then we go to our Cartesian plane. This is the minus 45, and this is the minus 90, and this is the 45, 90, 135, 180. So now from this question we see this indicates a change of period, and this indicates the amplitude, which is a half. So we have got here we have got 1, and here we have got negative 1. This is a negative a half, and this is a half. So negative 90, we have got a negative half somewhere there. Well, let's start with our zeros. Our zeros is at negative 45. Our zeros there. At 45, we got the zeros there. And 135, we got the zeros there. Then our maximum is at 0. At 0, we have got a half, which is the maximum there. And also at 180, we have got a maximum, which is a half there. Our minimum is negative 90. We have got a negative half there, somewhere there. So this was misplaced. Yes, negative a half there. And then we have got at 90. We have got a negative half there. Yes. So we start from negative half, going to 0, going up. Then we come down, and then we go up again. So now we are able to see I've got the first number, the last number, the zeros, wherever is the x-intercept, and our turning point maximum, and also the minimum. This is the graph, which is y equals a half cos 2x. That's perfect. A typical example where we are able to observe the horizontal shift coupled with a change in the period. So here we have got another question E, which has got a horizontal shift. So what was at 0 has been 45 degrees to the right. Now, if we look from what we have here, our period did not change. Period is 360. If we divide by 4 to get our critical angles, we have got 19. So now if we start from here, adding 90, we'll still get our values that we are looking for. So our critical angle would be minus 135, that's x, and then we have got our y value. Okay, now if we add the 90 here, if we add the 90, we will get minus 135. If we add our 90, we get negative 45 minus 45. If we add the 90 there, we have got 45. If we add 90, we have got 135. If we add the 90, would it be 225? If we add the 90, it would be 225 plus 90, 315. 315. If we add 90, we have got a 405. Excellent. Then we can go to our calculator to get our critical values. That will be sine x minus 45 minus 45. Our starting point will be minus 135 minus 135. Our end point will be 405, and our jump would be 90 degrees because the period have not changed. Okay, so here we'll get is 0 and negative 1 and 0, 1, 0, negative 1, 0. So we go to our Cartesian plane. Yes. Here we have got minus 45 minus 135, 45, 135, 225, 315, 405. What is our zeros? We have got a 0 here at 45, we have got a 0 here, 225, we have got a 0 here, and we have got a 0 here. Where is our maximum? At 135, 135, we have got, here's a 1, here's a negative 1, 135, got the maximum there. Where do we have a minimum? Negative 45, minimum there, and also 315, we also have minimum there. Okay, so here is a 0, here is a negative 1, then a 0, so we will go down, then go up, then come down, then go up again. So this is our graph, which is y equals sine x minus 45. Perfect. So we are able to see our x-intercept, our turning point, which is the maximum and the minimum there. That is perfect. So now here we have got a question where you have to put two graphs on the same set of axes. Yes. So now here we can have our, so if we look at the period has not changed. There's no change of period. So we'll go in the steps of 90s. Yes. And our domain that is given will give us all the critical values that we need. So here we can have x, and then here we can have f of x, and then we can have g of x. So we start with v minus 90. So if we put add 90, we have got a 0. Then we've got a 90. And then I've got 180. Yes. So then we go to our calculator. We have got f of x, which is the negative sine x, then the second one, now we have got sine x minus 2. We have got sine x and minus 2. Our starting point would be minus 90, and our end point would be 180, and our steps would be 90. So what we have here, we have got 0, here we have got 1, negative 3, 1, and the negative 3, and here we've got 0, and the negative 2, here we have got negative 1, negative 1, and negative 1, then we have got 0, and the negative 2. So we can now make our Cartesian plane. Here we have got minus 90, here we've got 90, here we've got 180. The biggest number is 1, then put 1 here, negative 1, negative 2, and the negative 3. So let's have one color for the first one. Let's have it as dark. So f, what do we have? 90, we have got, okay. Our zeros is at 0 and at 180. Our maximum, negative 90, we have got 1. And at 90, we have got negative 1. At 90, negative 1. Yes. So we will go down here and then go up there. So now let's take another color. So this is our f. This is graph f. And then you can use a blue. Yes. For G. G, we have shifted it 2 units down. So this becomes almost like our zeros. So where do we have a negative 2? We have got a negative 2 at 0 degree, at 0 degree here, and we have got again negative 2 at 180, and also there. So where do we have our maximum? Our maximum is negative 1, which is at 90. At 90, we have got negative 1, okay, which is there. Our minimum is at negative 90, which is negative 3. Negative 90 here, negative 3. Yes. So we will go up this way, hit there, and then come back there. Yes, so this will be our F, our G. So it looks beautiful. So it's important to understand the issue of transformation, the shift. So that was a good one. Now we have got a question here. If we look at f of x, here we have got, it's the same as our f of x equals cos 3x. Now here it means our period have been changed. So our period for this one, period will be 360 divided by 3, which will give us 120. If we divide this by 4 to get critical values, we have got 30 degree. So we'll be going on the increase of 30 degree. But for this one, the period have not changed. We'll be the increase of 90. But lucky enough, 90 is a subset, 30 is a subset of 90, it's a multiple of 30. So that will not be a problem. But again, what we're interested in for the sketching is only the critical values. At every 30 degree here, we get the critical values. But at every 90 degree, that's why we get the critical values for the g of x. Now, let's make our table. Here we have got, this will be a long table. Here we have got x. Okay. Then here we have got the f. And here we have got the g. Okay. So we move here, 30. Okay. 60, 90. Actually, I would have started with 0. Let me remove this one. I should have started with 0. Yes. I need to start with my 0. Okay. Now here we have got this one. Much better. 0 degree. Everything we need. Here I go 30, 60, 90, 120, 120, 150, 180, then 210, 240, 270, then 300, 330, and 360. Okay. Now I can go to my calculator and put in a value. You have got 3, it is cos. I've got cos 3x, and g of x is 3 cos x, and we'll go in the step of 30. Our starting point would be 0. Oh gosh, wait, what did I do now? We have got yes. Okay, start. We are starting at 0 degree. We will end at 360, and the step is 30. Yes. Now let me start with g, which would give me here 3. Then at 90, I've got a 0. Then I at 180, negative 3. At 270, 0. And at 360, 3. And then the other one now, which will give me plenty of element. Okay. At 0, I have got 1. Then I've got a 0. Then I've got negative 1. Then I've got a 0, 1, 0, negative 1, 0, 1, 0, negative 1, 0, 1. Okay. Then I make my Cartesian plane. So now here I've got 1, 2, 3, negative 1, negative 2, negative 3. And then you've got 90, 180, 270, 360. Now, yes, 30, 60, 120, 150, 210, 240, 300, 330. Okay, let me start with the easy one, which is my G. So I've got the zeros at 90, zeros at 90, and also at 270. I have got a maximum at 0, maximum, and also at 360, maximum. I have got a minimum at 180. Yes. So I would come down, hit this, and then go up and hit that. This is the graph G. I can now change the color and then deal with this other one. I have got the zeros at 30, zeros at 30, and then at 90, 90, then at 150, 150, then at 210, at 210, then 270, at 270, and then 330, and at 330. Okay. Then I have got a maximum 1 at 0, 1 at 0, and then 1 at 120, 120, and then 1 at 240, 240, and then 1 at 360, 360. I've got a minimum at negative 60, at 60. Then at 180, 180, then 300. Voila. So I will go down this way, go up that way, come down here, go up again, come down, and go up again. So if you see, we start here, come down, one complete. Start again, one complete. Start again, one complete. Basically, we put 3 complete graphs in 360 degrees. So that is perfect. So the other one has been stretched, but this one have been compressed. We're able to see the stretch and the compression. All those are part of the modification. Now I have got a good question here. Now with this question, we have got a horizontal shift. The graph have been shifted 30 degrees to the right, and this one has been shifted 30 degrees to the left. Now I want to do this in 2 ways. One, I will use a calculator, which does not really give us the critical value that we are looking for. And then I will also try to do it manually. Let me start maybe with manually. If I do manually, I see my period have not changed, which means I'm still moving in the step of 90 degrees. So I can have my x, and then I will have my f, and I have my g. Okay. So here, let me have both before modification and with modification. Or let me leave that one out. Okay. So now I can have 0 degree, 90, then 180, 270, and 360. And 360. So then, what is the sign 0? It will be 0. What is sine 90? Is 1 times negative 2, so negative 2. What is sine 180? Sine 180. So basically this is what we have. It's 0, which will give us 0. Sine 270 and negative 1. So to give us a negative 2. Negative 1, that's 2. Plus 2. 360 is a 0. Then let's go to cos. What is cos 0? Is 1 times that half, it will be half. What is cos 90? Is 0. What is cos 180? Should be negative 1, so be negative a half. What is cos 270? Should be 0. And the 360 should be 1, then a half. Now we go to our modification now. If we go to the modification, everything will be moved by this one. Okay. Now let's go to G. Now modification. Modification. Now here we are going to have X, then we have F and G. Yes. What was 0 here? Oh gosh, at different levels. Okay, let's have X here, and we have our G. Okay, we can have here. For G, we are going to have so we've got a plus. So we have got 0. We added the 30. That becomes 30. If we remove 90, we've got a negative 60. Of which we don't have a negative 60, but we have got negative 30. So we have got here negative 30 minus 30 with a number that I'm going to calculate, and then we are going to have where it was a 0, it will be 30. Now we have got a 30 and 0. Then from 30, if we add 90, 120, 120, and negative 2. Then we have got, we add 9 to 10, to 10 with 0, to 10 with 0, and then it will be 300, 300 with 2, and then 390, 390 with 0. Okay, now we go to the other one. So the other one, let me change color. So the other one, This is for F. This is for G. Now the other one, they have added 30, meaning we moved 30 degree to the left. So what was 0, it will be negative 30, which is perfect there. Okay, negative 30, it will be a half, 1/2. And then if we add 90 there, we're going to have a 60. 60 will be with a 0. And then 150. 150 would be minus a half. Then 150, 240. 240 would be with a 0. 240. Then 330. 330. 330 would be the one with a half. 330. Then we have got and for the 390. 390, we are going to get that number there. Okay, that's perfect. So then I can put it this one, yes. I've got minus 30 here. Minus 30. Then I have got 30. I've got 60. I've got 120. I've got 150. I've got 180. I've got 210. 240. 270. 300. 330. And 360. 390. So let me go to the first one. Let me use dark color. It's dark. For the first one, I can look for where it was. I have got minus 2 sine x minus 30. Then I've got a half cos x plus 30. Then the starting was negative 30. The end was 390. And I will remove 90. Yes. So here is 1,7. 1,7. Here there is 1,7. 1,7. We go to the last one. With 390. 390. 390. Maybe step, let's make 30 and see. Is the first one comma, and the last one 390, 2 comma 0.25, 0.25, 0.25. Yes. So now the first one here I've got 1, I've got 2, -1, -2. So 1.7 should be somewhere here. Then I will go to 30 and 0. Let's look for my zeros. 210. 210. I've got my 0 here. 390. I've got a 0 there. And then let me look at my maximum. I've got 2 at 300. 300, I've got 2. My minimum, I've got -2 to 120. -2 to 120. Yes. So meaning I will come here, pick there, and then come there. This is it. Y equals -2 sine x minus 30. Okay. And then I change the color now for the other one. And this is not an easy graph to make. So here we've got -30 and a half. Let me look at my zeros. At 60, and then 240, 240. Yes, my maximum is in a half here, I put half here, and then another maximum is at 330, 330 here, half, and then at 390, 0.2, maybe somewhere. My minimum, I have got at 150, 150 minus a half, somewhere here, and yes. So it will come going down here, then go up there, then come down again. Wow, a tough one. So this was y equals a half cos x plus 30 plus 30. Okay, it's much better. So now if I have used this, I was not going to get my critical values. So if I used this, this -1, -1, -2, yes, I would have got, but with so many the value that I did not need. So basically, on each graph, I'm able to consider the modification which was done and the angle that will give me what I'm looking for. The first number, the last number, the zeros, the maximum, and the minimum. So a complicated question like this, you can do it manually rather than using a table from the calculator, because it helps you to work out the angle that you are looking for. Yeah, challenging. Now, on this question, we are able to see that with tiny graph, we know that the period change to 180, and also we have to observe the asymptote. Yes, so period will be equal to 180. If we divide by 4, we get the 45, which is our steps to give our critical angles. So basically, since there is no change and there is no horizontal shift, we can use our calculator to get what we are looking for. Here we have got the tan x minus 1, and for g of x, let's start 7. Okay, our f of x is equal to 2 tan x, oh gosh, no, is equal to tan x minus 1, tan x minus 1, and our g of x is equal to 2 tan x tan x. So our starting point is negative 90 degree, the end is 180, and the steps will be 45. Then we can have our table. Here we have got x, the angle. Here we have got the f, and here we've got our g. Okay, so minus 90, then minus 45, minus 45, 0, 45, then 90, 135, and 180. Okay, so now we have got undefined, and then I've got negative 2, minus 2, 0, minus 1, 0 and 2, undefined, minus 2, minus 2, and I've got minus 1 and 0 and 0. So then you can have our Cartesian plane. So you have got minus 45, minus 90, 45, 90, 135, 180. So let me start with the first one. I will start with the asymptotes. This is our asymptote, and also I've got asymptote 90. Asymptote. Now we will go to our zeros. We've got a 0 at 0 and 45. Does it make sense what I have here for f? What do I have for f? So I have got undefined, then -2, -1. This is -1, -1, 0, undefined, -2, and -1. Yes. So here I'll have -1. Here there is 1. Here there is 2. -2. So I have got undefined days. Then I've got a 0 at 45. 45, I've got a 0. Yes, I've got a 0 here. Okay. Then I have got my maximum is -1 at 0. At 0, here I've got -1. -1. At 0, I've got -1. At 180, also I've got -1. Then I've got a -2 at 45, -45, the -2. And I have got 135, also -2. -2. Okay. So now I have got define. Yes. So I have got it coming from undefined all the way, then coming there all the way to here. Because I remember it has shifted -1. Where's the -1? Yes. Yeah. Tan x -1. Yes. It was 1, came to 0. Yes, that makes sense. Yeah. Now let me change, put the other one. Let me use this red. Here also we have got to have stretched the graph. So 0 is at 180. At 180 we have got a 0. Okay. But what we have at 0, this may not be correct. Let me see again. Yes. -2, then is 0. -2, this was a 0. -2, then 0, then 2, error, -2 and 0. Yes. So my zeros is here and there as well. Here also there is a 0. My maximum is at 45, where I have got 2. Where is my graduation now? Here is 1. Here is 2. Here is -1. Here is -2. So I've got a 0 here and a 0 there. I have got a maximum at 45. 45, I have got 2. And I have got a minimum at -45. -45, I've got -2. And then at 135, also -2. -2. So now so tapping closer to this, closer to here, and then come again closer to this and coming there. Yeah, this one is our G. This one was our F. Not the beautiful graphs, but this one has been stretched. This one has been stretched, and the other one has been shifted 1 unit down. That's how we are looking. That would be perfect. Let's look at the other kind of question that. So here we have got a typical question where the graphs might also have some elements of general solution. We have got tan x here, f of x, and g of x, which is sin 2x, and we are given the domain. Now they want us to get the general solution. So if we have got tan x equals sin 2x, so we need to be able to find our general solution. We can change this using our identity. We know that tan will be equal to sin x over cos x. And you can also use our double identity to this one, which will be equal to 2 sin x cos x. Now we go to our knowledge of grade 9 to get rid of fractions. Basically, with times here, multiply by cos x. We also multiply here by cos x. So what we have here, it would be sin x would be equal to 2 sin x cos square x. So now this we can treat as a quadratic equation where we have got 0 to be equal to 2 sin x cos square x minus sin x. So if we can take out, because here we've got now 2 terms, one term and another term, and something is common, sin x. So we can have 0 equals sin x. Then we have got 2 cos square x minus 1. Okay. So now we have got 0, which is equal to, so this is the same as um, it's a 0 factor, call it 0 factor, 0 factors. So 0 equals to sine x or 2 cos square x minus 1 equals 0. So now if you look at this one, is also the double angle identity, where you can have cos 2x equals 0. Now our reference angle here, would be equal to 0 degree. And now here we have got x would be equal to 0 plus 360k, or x will be equal to 180 minus 0 plus 360k. And now here, for this one, here we've got cos 2x equals 0. So our reference angle would be equal to 90. Yes, 90, because so now I've got 2x, which is equal to plus minus 90 plus 360k. So I've got the x, which is equal to plus minus 45 plus 180k. So x will be equal to, yes, that's what it is. Now we go to, that's the answer for number A, our general solution. So we have got x, which is equal to 45 plus 180k, or x equals minus 45 plus 180k, or x equals 0 degree plus 360k, or x equals 180 degree plus 360k. Now we go to number B now. We are looking at a range of negative 90. We can have, maybe let's make it negative 1. Make it negative 1, 0 and 1. If we put negative 1, this one would be bigger. Negative 1, negative 1. Okay, let's put 0. We get 45, and we will get minus 45, minus 45, and then 0, and then 45. If we put 1, here, 1, it will be 135. Yes, 135, 135, and if we put 0 here, also 180. Put 0, so it will be 180. Yes, 180 also is a part of the solution. Yes. So now what are these? So these are for number B. Number C, these are angles where the two graphs are equal. Points where two graphs are equal. Yeah. So it's a typical question where you have got the general solutions and the solution that specified the domain all coming together within trig functions. We have got two graphs. This one period, it's 180. If I get 180 divided by 4, I get 45. Here, period is 360 divided by 2, 180 divided by 4 is 45. So I would have the same steps of 45. Then I can have my table. Here I've got my x, I've got my f, then I've got my y. Okay. So I have got minus 90, minus 90, minus 45, then 0, 45, $90, 135, 180. Okay. So now I can bring this into my calculator. Here I've got the tan x minus 1. Then we have got cos 2x, then minus 90 to 180, 45. Yes. Now here, what I have, I've got an error here, undefined, and then I've got -2, -1, 0, undefined, -2, -1. And then for the other one, I have got -1, 0, 1, then 0, -1, 0, 1. Okay. I go to my Cartesian plane. Here I have got minus 45, minus 90, 45, 90, 135, 180. Then I have got my 1, 2, -1, -2, and it goes. So I can start with my undefined. It's at -90. There's an asymptote here. Then again at 90, I've got an asymptote there. Then I've got my zeros at 45. 45, I've got 0. I've got my -2, minus 45, negative 1 here, then 135, 135 negative 2, 180 negative 1. Yes, so start from undefined, going up, then starting here, going there. Okay, then I go to the other graph, make it yellow. I've got my zeros at negative 45, negative 45, and at 45, and at 45. I have got my, and also at 135, 135. I've got my maximum at 0, which is 1, and also 180, which is 1. And then I've got my minimum, negative 90, which is minus 1, and also at 90, negative 1. Yes, so I'm going up, then down, go up again. Okay, that's good. So now I'm asked to sketch the two graphs on the same set of axes, and then they want me to find, what is it now, the values of x, where they want where tan x equals to cos 2x plus 1. So basically where the two graphs are equal, so that would be here at 45, they are equal. Yes, at 45. Any other point where they are crossing here, and then nowhere else. So therefore, for this one, x equals 45 degree. Yes. What else are they asking? They're asking where 2 cos x minus 1 to 2 cos squared x minus 1 equals 0. Now this one is identity, is the same as cos 2x. Where is it equal to 0? This is a gram, so this one, that's the point. Let me use different color. So it's equal to 0 at this point, and also at this point. So I've got the x is equal to, or x is a member of here we have got minus 45 degree, and then we have got 45 degree, and we have got 135 degree. Let's go to number 3. They are looking for value of x where f of x is negative. Here we have got f of x equal, or which is less or equal to 0, where it is negative, and f of x is the same. Yes. So here we have got 90 degree, and we have got where it is negative, and we have got 45, and we want x to be in between. So we want x to be greater than and less or equal to that. Or then we have got 90 and we have got 180 and x in between. You want x to be bigger than that, less or equal to that. So those are the values of x where we are able to see those. Yeah. So let's see what's there on the number 4. So number 4, I can put it here. We are looking for the value of x where g of x is greater than 0. It's positive. That's a green. Where is it positive? It is positive 45 and minus 45 and 45. X in between. We want x to be greater than and less than. Or we have got again 135 and 180 and x in between. We want x to be bigger than that. So yes, and also being equal to less or equal to that. Those are values. Yes. We go to number 5. What are they asking at number 5? They want where f of x is greater or equal to g of x. So where f of x is greater or equal to g of x. So where is this red one greater? It's only greater between, I've got 45 degree and I've got 90 degree. So x in between. Now we want this one to be greater or equal to that, but want to be less than that one. We go to question 6. What's the other question 6? We have got where f of x is less or equal, is less. F of x less than g of x. We want this one to be less. So there we have got 90 and 45 minus 90 and 45 degree. So at this point, it is within this region wherever the graph is below. So now we want x to be greater than 90 and also to be less than 45, or I've got to get 90 and 180. So x in between. Yeah, I want x to be greater than 90, but less or equal to 180. It's also part of a solution. Then we go to number 8, number 7. If you go to number 8, we have got where f of x times g of x is equal to 0 positive, meaning they should be either on the same or on different, negative and negative, or positive and positive. Okay, let's see. Here they are all negative, so meaning we have got 0 and 45. 90 minus 90 and 45. So x in between should be greater less or equal there. And then here positive, negative, here they are all equal. Here positive, this one negative, but here they are all negative. This to this 90 and 135. I've got positive 90 and 135 x here. And this to be greater or less or equal to that. That's the point. Now we want to see 9, where f of x times g of x, it's less than 0, negative, meaning they are at a different region. Now here same region, here this one is positive, the other one is negative, so between 45 minus 45 and 45 minus 45 and 45 exit in between want to be negative, so this equal, this one should be less. And then also here it's positive, this one you see negative, meaning I've got a 45 and I've got a 19. X in between, excluded. Now we've got again negative, but it's positive. Yes, 135 and 180. X, we want x to be greater, less or equal to that. So I think I can end here. These skills on the interpretation part is the same what we do with calculus and also with the function. Let me end here. I hope one have enjoyed this lesson.